Hey everyone, welcome to my channel. In this video, let's solve a couple of problems together, word ladder and word ladder 2. This is a really interesting problem, so let's dive into the problem now. We are given a begin word and an end word and a word list dictionary. We have to find the length of the shortest transformation sequence from the begin word to the end word. So that is word ladder. And we have to find all of the shortest transformation sequences, and that is word ladder 2. Now, what is a transformation sequence, or what is a transformation in the first place? Okay, if you take this example here, hit to hot is a transformation because there is a change in one character, that is I is replaced with O, and this transformed word is part of this word list dictionary. Similarly, hot to dot is another transformation, and dot, the transformed word, is part of this word list dictionary. So hit to hot, hot to dot, dot to dog, dog to cog, and cock to cow is a transformation sequence from the begin word to the end word. So begin word is hit and the end word is cow. And all of these transformed words are part of this word list dictionary, excluding the begin word, of course. Okay, now the length of this transformation sequence is equal to 6. Similarly, hit to hot, hot to lot, lot to log, log to cog, and cock to cow is another transformation sequence with a length equal to 6. Now there are other transformations that are possible. For example, hit to hot, hot to dot, dot to lot, lot to log, log to cog, and cock to cow. So this is a transformation sequence, but the length of this transformation sequence is equal to 7. So our objective is to find only the shortest transformation sequences from the begin word to the end word and its length. So how do we solve this problem? Okay, first let us try to identify the data structure that can be used to solve this problem. Now, the transformation sequence from the begin word to the end word can be represented using the graph as we can see here. So hit to hot is a valid transformation because I is replaced by O and hot belongs to this word list. Hot to dot or hot to lot is a valid transformation because both words dot and dot belong to this word list. Dot to dog is a valid transformation because dog belongs to this word list, as well as lot to log is a valid transformation because log belongs to this word list. Dog to cog or log to cog is a valid transformation because cog belongs to this word list. And cock to cow is a valid transformation because cow belongs to this word list, and this is our end word. Now the shortest transformation sequence from the begin word to the end word there are two of them: hit to hot, hot to dot, dot to dog, dog to cog, cock to cow. So this is one transformation sequence, and the other one is hit to hot, hot to lot, lot to log, log to cog, and cock to cow. So this is the second transformation sequence, the shortest transformation sequence. The other transformation sequences that are possible are hit to hot, hot to dot, dot to lot, lot to log, log to cog, and cock to cow. Now the transformations at the same level increase the length of the transformation sequence. And also it introduces a cycle here if you look at this graph. So we shall ignore all such transformations. Okay, now what are we trying to do? We take a word and try to find all possible transformations for that word and check if those transformed words belong to this word list. Now in terms of graph, so we take a node and find all of its neighbors. Now what is a graph traversal that can help us in achieving this objective? So it's a breadth first search, or BFS. Now what is a data structure that can be used to solve problems related to BFS? It's a queue. So now let's use a queue and see how we can achieve this objective. Okay, now the idea is pretty simple. We initially offer the begin word to the queue and start processing the words in the queue level by level. So at level 0 there is only one word, that is the begin word. So we take that word out and start transforming it. Now whenever we find a valid transformation, we shall record it in this hash map and also add the transformed word back to the queue. Now whenever we find the end word and there are no more words to process in the queue, that's the end of the processing. The total number of levels will give us the length of the shortest transformation sequence. So that is the solution to word ladder. And then we shall use this hash map to build the shortest transformation sequences. So that is word ladder 2. Now let's see how we can do that. Okay, now let's start this by offering the begin word to the queue. So we shall add hit to the queue. Okay, now the queue size is 1. Let's start processing the words in the queue. So we shall remove this word from the queue, we shall poll it and assign it to this current word variable. Okay. Now we shall transform, now the queue size is equal to 0. Okay. Now we shall transform this word hit by replacing every character with letters A to Z. So let's try replacing the first character. So with AIT. AIT, the word AIT doesn't belong to this word list. So we shall continue until we find a word. So we find hit here. Hit is same as the current word, so we shall ignore such words. So we shall continue this until we find a word that will belong to this word list. Okay. Now none of these words belong to this word list. Now let's move to the next character. So let's replace this HBT, etc. Somewhere in the middle we find hot. Now this word belongs to this word list. So we shall create a mapping between this word hit and hot. So hit to hot. We shall offer this word hot to the queue. Okay. And also we shall mark hot as visited. Now we shall continue this process until HZT. We can try replacing the other characters, the last character, HIA, HIB, etc., HIZ. And none of these words belong to this word list. Okay, now we are done processing this word hit. And there are no more words in this level. Now whenever we are done processing a particular level, we shall remove all the words that are marked as visited in that level. So in this level hot, we marked hot as visited. So we shall remove this word from this word list. The reason is we don't want to revisit this word again from the new level. Okay, now we shall move to the next level. Okay, now we are moving to level 1, and in level 1 once again we have only one word, right? So we shall poll this word and assign it to current word. Okay, now the size is 0. Okay, now once again we shall start replacing this word, this first letter, and see if we can find a word that belongs to this word list. So there's a word dot that belongs to this word list. So we shall mark this word as visited. We shall create a mapping between word hot and dot. And also we shall offer this word to the queue. And okay, now we shall move. We shall continue this. So somewhere in the middle we find lot. So lot is also a word that belongs to this word list. So we shall mark this as visited. We shall add the mapping between hot and lot as well. Okay. Now we can continue. Okay. We shall also offer lot to the queue. Okay. And we can continue this until 0t. Now we can replace the second character as well. And we can continue this until HCT, and none of these words belong to this word list. You can try with the third character as well. So yeah, and we HOZ, and none of these words as well belong to the HOA, belong to the word list. So now we are done processing this word hot, and we are also done processing the word in this level 1. So now what we'll do is, before we move to the next level, we shall remove all the words that have been marked as visited, that is dot and lot. The reason is, once again, we don't want to revisit them, so we shall remove them from the word list. Now we are done processing this level, so we shall move to the next level 2. Okay, we have already polled this word. Now because space constraint, I shall move these words here. Now in this level 2, we have 2 words to process. So first we'll poll the word dot. We shall try replacing this word again. So we can try with AOT, BOT, etc. So we'll find LOT in the middle, that is already part of this queue, and we don't see that word. So, and ZOT. Now we don't find any other word that belongs to this word list. Now let's replace the second character, DAT, DBT, etc., DZT, and none of these words belong to this word list. Now let's try replacing the third character. So DOA, DOB, etc., DOG. So we find this word that belongs to this word list, right? So we shall mark it as, okay, this is DOG. Now we shall mark this word as visited, and we shall create a mapping between dot and dog. And we shall add this word to the queue. We shall offer this word dog to the queue, and we can continue processing until DOC. Now none of these other words belong to this word list, so we are done processing the word dot. Okay, now let's move to the next word, which is lot. We are still in the same level because there are two words in this level. Okay, now let's move to the word lot. So we shall pull that word from the queue. Now let's start replacing every character in this word. So I'm not going to show all the combinations, but from lot we shall get the word log. So log belongs to this word list. So we shall mark it as visited and create a mapping between lot and log. Okay, and we don't find any other word that belongs to this word list. So once we are done processing the word lot, now there are no more words to process in this level 2. So we shall remove the words that are processed in this level, dog and log, I'm sorry. So okay. We shall also add the word log to the word log to the queue. Okay. Now we are done processing the words in the level 2. Now we shall move to level 3. Once again, because of space constraint, I shall move these words here, dog and log. Okay. Let's remove this. Now let's pull the word dog from the queue. Okay, we'll remove it. Now we shall start replacing the words, the characters, first character, so AOG, BOG, and then we'll find 𝐂𝐳, So 𝐂𝐳 belongs to this word list, right? So we shall create a mapping between dog and 𝐂𝐳. Okay, now we can continue this until ZOG. You can also try other combinations, and we don't find any other word that belongs to this word list until DOZ. Okay, so we are done process. Okay, we shall offer this word 𝐂𝐳 to the queue as well. Okay, now we are done processing the word dog. Okay, now still there's one more word which is log in this word list, in this level, I'm sorry. Okay, now we can start replacing the first character in this word, AOG, BOG, etc. We'll find 𝐂𝐳 once again. So we create a mapping between log and 𝐂𝐳. Now we've already marked, okay, I didn't mark it before, so I should have marked it earlier. So 𝐂𝐳 is a word that was visited by dog as well, right? So log also has a mapping with 𝐂𝐳. So we shall mark it as visited. We can continue until LOZ, and none of the other words belong to this word list. Okay, now we are done processing the word log. Okay, I should have removed this as well. Now we are done processing the level 3, all words in level 3. So we shall remove the words that were processed in this level, that were marked as visited here. Okay. Now we are done with level 3. Now we shall move to the new level 4, and we shall pull this word 𝐂𝐳. So now we shall transform the word 𝐂𝐳 by replacing every character here. We'll try all combinations, and none of these words belong to this word list. We'll try with the second character, and none of those words belong to the word list. And we will try with the last character, and somewhere at the end we'll see cow. Now this word cow belongs to this word list, so we shall add a mapping between cog and cow. We shall also add the word cow to the queue, and we can continue this processing until the word 𝐂𝐳, and none of the other words belong to this word list. So okay, so we are done processing with this word cog. Now since we have found the word cow, so we shall mark it as found, and once we are done processing the word 𝐂𝐳, then we move to the new level. So whenever we move to the new level, we remove all the characters, all the words that were visited in that level. So we should remove the word cow from this word list. Now we shall move to the new level, which is 5. So I'll remove this. Okay, now in this new level, once again we have just one word cow, so we shall poll that word. Now this current word cow is same as the end word cow, which is the required word. So that means we have found a transformation sequence from the begin word to the end word in this hash map. Now the length of the actual transformation sequence, the total length, is equal to this level here 5 signifies that there were 5 transformations from the begin word. So that means the total number of transformation, the total length of the transformation sequence is equal to level plus 1, which is equal to 6. The length of the transformation sequence is 6. Now this is the solution to the problem word ladder. Now we shall use this hash map to find the actual transformation sequence. We shall build the actual transformation sequence using the backtracking technique. Now let's see how we can do that.